Hello, I'm Craig Waters, editor of Global Railway Review, and joining me on this video is Hansen Chan, IP Product Marketing Manager with a focus on industries at Nokia. Hansen, good to see you, and thanks for speaking with me.
Yeah, likewise, Craig. Nice to see you today.
Fantastic. So Hansen, I wanted to spend some time with you today to explore a little more about how digital rail can fast-track rail communications networks. But my first question to you is more about the term digital rail. And we frequently hear this term in the industry. So, but what does it actually mean? So what does it really encompass? What are your thoughts around the term digital rail?
The term digital rail actually can have a very broad meaning. If you ask 5 people in the industries, you may get 7 or even more answers. But I think the common denominator of those answers is that, it is the heavy use of course, digital technology, in particular, a lot of software. However, I think I would take the answer a bit further, but along the same direction. A digital rail, I think, is a rail system that has not only the physical assets like tracks, trains, rolling stocks, but also a lot of digital assets, which include, data and application software. Digital rail would collect a lot of data, across the rail infrastructure, right? Particularly operational data in real time, right? And those data will be brought back, to where the digital software, the application software, are hosted, right? To consume and process, to operate, right? For a high degree of automation, for more intensive monitoring, right? And so on, right? And so basically, I think in the past, of course, data and software are always there, but in a digital rail, data and software plays a much more prominent position. And speaking of software, I think I have to bring out one point. Like software development, and paradigm has, changed. Like in the past, software is developed, of course, by many teams, but the output will be integrated into one big monolithic, piece, one process. But in the past 10 years, we see that the cutting-edge software development, paradigm is moved right to a more modular microservices based, meaning that each team will produce a different microservices module that run independently. They will be deployed independently, right? Of course, work together, and it's suitable for a cloud environment. When we speak of cloud, I think people think about, the public cloud, is a location. But I would bring out the point that cloud is actually more about how compute is being managed and the compute is being consumed, right? So with a lot of new software, particularly a lot of OT, operational technology software, like SCADA, train control management system, and so on, they are developed in a microservice-based cloud environment, right? So a private cloud, like an OT cloud for OT software, plays a more and more important part in the digital rail, infrastructure.
Great, yeah, absolutely. And I think one of the talking points that I wanted to raise with you, Hansen, is more about the role of communications networks within a digital rail system. So perhaps you can talk us through a little bit more about that. What insight can you give around that area?
Communication networks, of course, is to connect things, right? People, machines, servers, application software, right? And has been playing a critical role, even today, right? Connecting physical assets like a colored signal light, track switches, right? And radio tower for land mobile radio, right? So those are very common things to connect. A digital rail communication network will do all this plus a lot more. I think most important is to understand that in the digital rail, there are more physical assets, like from IoT, devices to more, interlocking computers, right? And next generation wireless system, radio tower, right? To connect, right? So there will be a lot more data to be transported. So there are more devices to connect, more assets to connect, more data to transport. You need a bigger capacity with more extensive reach, right? So the IoT sensors are now deployed extensively, right, in digital rail to monitor from the train axle vibration to watch for tear and tear, right? Track temperature, wind speed, right? So a lot more data to be brought back to the data center or the OT cloud for the application to consume, right? To monitor the situation. And also in a train station, now we see there are more and more cameras, CCTV cameras to be deployed, Wi-Fi access point, more customer display, right? So all this would also generate more data, right? So I think the data is now being brought over the network, and you can consider the network actually as a digital rail, a digital track of a digital rail, right? So the train does not just run on the physical track, but you also run, on the network as a parallel digital track.
Okay, good. That's interesting. So just moving that forward in terms of when we consider the future and looking at how things need to evolve. My next question, Hansen, is how is the digital rail communications network requirement, how is it different from that of current rail systems? And how should networks evolve to support those new requirements? What would you say?
Yeah, I think as I mentioned a couple of times just now, right, there are a lot more digital assets. A lot of physical assets, whether they are, along the track, right, or they are in a train station, or they are on board, right? And so those are very different physical environments. So the network need to expand its reach. However, the way to access those physical assets would be different depending whether the physical assets are along the track or in a station or on board, right? So if you look at the example of along a trackside IoT, you need more fiber optics, right, or microwave link, right, to reach them. If they are inside a train station, so with more CCTV cameras, so you need to have a more robust, higher capacity train station network. If they are on board, right, then you need to beef up or strengthen your train to ground communication, right, with not just a narrowband radio system, but with a more broadband, wireless system, right? So you need to beef up, to the access domain. And in the backbone domain of the network, right, now we see more and more applications. In the past, I think the paradigm is to deploy one network for one application, but with the exploding number of applications, you really cannot adopt the same model, right? You need to design and plan for a converged network, a converged backbone that can support multitude of application, and as application is deployed, you just keep on top of one another in the converged network, but with segregation of resources to assure performance. And then I think the last piece is, as we mentioned about the emergence of OT cloud, right, that would host all these new application software, right, which are essential digital assets. So the data now is collected in the access domain, transported by the backbone, and now reaching the data center or the OT cloud. It has to travel one more leg, one more domain, which is the data center network, or the fabric in IT speak, right? The fabric or the data center network essentially is a fully meshed leaf spine network, connect all the servers in the OT cloud, where the data is being stored and application software are being run, right? So essentially, I think the railway communication network need to evolve to accommodate, these three things in the access domain, in the backbone domain, and also in the OT cloud data center.
Okay, good, thank you. And yeah, you mentioned there about the OT cloud. So with the critical role that the OT cloud plays in digital rail, Hansen, what do you believe are the key considerations that rail operators should keep in mind when designing and implementing an OT cloud fabric? What would you say to that?
Yeah, I think by now, I hope we all recognize the importance of the fabric itself, right? Because it is really, part of the mission critical communication path between the physical asset and the digital asset, right? Which are essential for safe and efficient rail operations. For example, just to reinforce the point, the SCADA remote terminal unit, the RTU, would be along the track side, right? Communicate with the SCADA front end or SCADA server in the OT cloud. So you would traverse the trackside network to through the backbone and then the OT cloud fabric, right? If there is a network fault, right, in the backbone, today, right, it will affect your visibility. But if you have a fault in the fabric, right, it will also equally affect your visibility, right? So that you may even have to consider stopping the service, right? Because it may impact your safety, consideration. So that's why I think the OT fabric need to be resilient, in the same way as your mission critical backbone that you have designed today, right? 5 nines or even a higher availability. So secondly, the fabric need to communicate, with all the devices, right, in the field across the infrastructure through the backbone. You need to have a seamless inter-networking capabilities between the DC fabric and the backbone. So the DC fabric, is based on technology like VXLAN, EVPN, Ethernet VPN, BGP routing protocol, while the IP MPLS backbone is based on MPLS and also BGP routing. So you need to have a DC gateway, that would join these two domains seamlessly in the routing plane, in the data plane, and in the service plane. And lastly, I think the fabric also needs to be really modern with cutting edge, IT automation agility. Because as we move forward, I think we can only see more and more software applications are being, used, right, to run the rail, right? There will be new application, new update, development, right? You need a fabric that is responsive to the application layer, and also be able to leverage if you have any IT automation or ecosystem, right, that you can work, with to increase the efficiency of your DC fabric, for your OT cloud. So you need to have both, the OT mindset, right, to be resilient, robust, right, and performance assurance. At the same time, with the modern IT mindset, that to be agile and support automation.
Excellent. So really, Hansen, it's clear that digital rail technology can revolutionize rail communication networks by enabling faster and more efficient transformation of data. So thanks for sharing your insights. In conclusion, do you have any final words to say to our viewers, what the future holds, or your recommendations perhaps on the topic?
Yeah, I think we are living in a very interesting time, Greg. The business environment, right, the technology landscape and the customers, preferences are changing at an accelerated pace never seen before, right? I think enterprises in general need a stronger digital infrastructure, right, to adapt to these exponential changes. And railways are no different, right? I don't think we can overemphasize the importance of communication infrastructure, right, to support the railway industry, right, to succeed, in this, changing and shifting environment. I think we are going to see more and more railway operators refreshing the network, right? Introduce, OT cloud with more applications, right? To strengthen their digital capabilities, right? To serve the customers to be more competitive, right? While not jeopardizing any safety and security, right? I know for the customers.
Absolutely. Thank you very much, Hansen. That brings us to a nice close. Thank you so much for joining me. Really great to get your insights on this.
Thanks for having me, Craig.
Thank you, and goodbye.
Okay, goodbye.